It all began quietly. No blaring alarms. No breaking news headline. Just a series of data packets silently streaming down from a spacecraft parked a million miles from Earth, delivered not with fanfare, but with a cold precision of photons bouncing off a segmented mirror larger than anything humanity had ever placed in space. The James Webb Space Telescope, a marvel of modern engineering and human ambition, had begun to see the universe in wavelengths never before visible to human eyes. But somewhere in that sea of stars, in a corner of sky that most of us never even glance at, it saw something else, something so unexpected, so profoundly strange, that it forced a group of seasoned scientists to sit in stunned silence, questioning everything they thought they knew. The telescope had been launched not to find aliens, at least not directly. It was designed to peer into the ancient past, to glimpse the first galaxies that ignited after the Big Bang, to probe the atmospheres of distant exoplanets, and to study the physics of black holes, dark matter, and the birth of stars. It was a cosmic time machine, tuned to infrared frequencies that could cut through dust and distance like a surgeon's scalpel. But in the course of this noble quest to answer how the universe began, James Webb stumbled upon something even more tantalizing. Something that may suggest we are not alone. The beginning of this incredible story starts with a planet just one of the thousands the telescope was programmed to study. It wasn't especially remarkable at first glance. Roughly Earth-size, located within the habitable zone of its star, and orbiting a relatively quiet red dwarf about 120 light-years away. Its name, as cataloged by astronomers, was simply K-18b, a sterile designation for what could be one of the most extraordinary discoveries in human history. The telescope had been gathering spectrographic data on this world for weeks, parsing its atmosphere for any signs of molecular composition. This is routine work for space telescopes. By analyzing the starlight that filters through a planet's atmosphere as it transits its host star, astronomers can determine the presence of gases like water vapor, methane, carbon dioxide, and even oxygen. These chemical fingerprints tell a story about climate, geology, and possibly life. What Webb found in the atmosphere of K-18b was, at first, confusing. The initial readings showed a clear presence of methane and carbon dioxide, two gases that, on Earth, are produced in large quantities by biological organisms. This alone was enough to raise eyebrows. Abiotic processes can produce these gases, but the specific ratio and the consistency of the data pointed to something far stranger. But that wasn't all. Hidden within the data was something no one had seriously expected to find. Dimethyl, or DMs on Earth. This compound is almost exclusively produced by living organisms, specifically marine plankton. There is no known natural non-biological mechanism that can produce DMs in significant quantities. Its detection on an exoplanet immediately raised one burning question. Was this a signature of alien life? The scientific community was cautious, as it should be. After all, extraordinary claims require extraordinary evidence. DMs could be a false positive. The signal might be contaminated, or the result of instrument noise, or an unknown geochemical process alien to our experience. But as the data continued to pour in, the signal only grew stronger, and with each new pass of the planet, the spectrograph confirmed that DMs was present, along with methane and carbon dioxide, and in proportions that strongly mirrored Earth's own biosphere. Whispers began to circulate behind closed doors. Peer review committees convened in secret. Draft papers were circulated in hushed tones among elite research institutions. NASA, ESA, and the Canadian Space Agency, all partners in the James Webb mission, had to grapple with the magnitude of what this might mean. Had humanity, for the first time, detected the chemical signature of alien life? Was K-18b not just a habitable world, but an inhabited? But this wasn't science fiction. This was science fact, or at least data edging perilously close to it. The public wasn't told immediately, not because of conspiracy or cover-up, but because of the weight of responsibility. Scientists needed time. Time to rule out errors. Time to replicate the finding. Time to understand what exactly they were looking at. The James Webb team quietly ran simulations, fed the data through new models, and consulted biochemists, geologists, and planetary scientists. Could volcanism be responsible? Could exotic atmospheric chemistry mimic a biosignature? Every angle was examined, every alternative exhausted, and yet the answer always came back to the same unsettling possibility. The most plausible explanation for the observed data was life. When the news finally broke, it didn't hit like a meteor. It seeped. A press release here, a scientific preprint there. Headlines cautiously danced around the word alien. They used phrases like potential biosignatures and unusual atmospheric chemistry. But the implications were clear. For the first time in history, humanity had observed something that might be the breath of another world. People across the globe stopped and stared skyward. Churches held vigils. Stock markets wobbled. Politicians stumbled over their words. The Vatican issued a statement. Social media exploded with speculation, memes, debates, and for a moment, the endless noise of everyday life paused, and all eyes turned toward a distant, invisible speck of light in the constellation Leo, and yet many remained skeptical. As they should. Science demands skepticism, not belief. The presence of dimethyl, sulfide, and methane, even in the precise ratios observed, is not proof of life. It is a cluper. Perhaps the most compelling clue we've ever found, but a clue nonetheless. It raises more questions than it answers. If there is life on K21AB, what kind of life is it? Is it microbial? Complex? Sentient? Does it dwell in oceans, in clouds, beneath the ground? And if life exists there, how did it arise? Did it follow the same biochemical pathways as life on Earth? Or does it represent an entirely alien genesis? Are we looking at a second genesis of life? In the universal evidence that life, once sparked, is inevitable wherever conditions are right, the James Webb Space Telescope has no cameras to snap photos of alien forests or cities. It cannot transmit images of creatures swimming beneath alien seas. What it can do is listen to the chemistry of alien worlds, to the vibrations of atoms and molecules shaped by forces we may not fully understand. Its instruments are ears and tongues, not eyes. It hears whispers in the dark. And what it heard from K218b was a whisper unlike any before. The response from the global scientific community has been a blend of excitement and restraint. Papers are now being published in top journals, cautiously interpreting the results while emphasizing the need for further study. Plans are underway to point to their instruments both on Earth and in orbit toward K218b to verify Webb's findings and perhaps gather additional data. Ground-based telescopes using adaptive optics and next-generation infrared sensors are being tasked with follow-up observations. Meanwhile, theoretical models are being revised to account for the unexpected presence of these molecules in exoplanetary atmospheres. Conferences are being organized. Panels are forming. The question is no longer, could life exist out there? But rather, how can we be certain? There is also the looming specter of falsehood. In the past, humanity has leaped too quickly at shadows. From the canals of Mars to the wow signal, we've misread nature's whispers before. But this time feels different. This isn't a blurry photograph or a one-off radio blip. This is consistent, repeatable, multispectral data from the most advanced space observatory ever built. If this is a false positive, it is the most convincing one yet. What comes next could redefine our place in the universe. Missions are being proposed to study K218b more closely. Some even dream of sending interstellar probes, though. That would take decades or even centuries. In the meantime, Scientists will continue to sift through Webb's vast ocean of data, examining other exoplanets with similar signatures. Perhaps K218b is not unique. Perhaps life is common. Perhaps we've simply been blind to it until now. And so, the question lingers in the air, as it has for centuries. Are we alone? The James Webb Space Telescope may not have answered that question definitively, but it has pointed a trembling finger toward the stars and whispered, "Maybe not." The mystery deepens. The story is just beginning, and humanity, for the first time, is no longer merely watching the cosmos. We are hearing its secrets one spectral line at a time. The aftermath of the discovery was unlike anything the scientific community had experienced before. In laboratories, observatories, and university halls, the world's leading minds were thrown into a frenzy. The implications of the James Webb Space Telescope's findings on K280b spread like wildfire, igniting debates, dividing opinions, and challenging the very frameworks through which we interpret the universe. Still, amidst all the noise, one quiet truth echoed louder than ever. Something was out there. Something was breathing. And if that was true, then humanity was no longer observing the universe from the outside. We were part of a much larger conversation. But science does not rest on implication or wonder. It demands precision, repetition, and scrutiny. So as the first wave of excitement began to settle, a second, more cautious wave emerged: verification. Could the James Webb readings be flawed? Could dimethyl sulfide be a misreading of another compound, or a trick of stellar light filtered through complex atmospheric haze? While no known abiotic processes produce DMs in those quantities, scientists were not ready to claim alien life on that basis alone. And so began the crossing. Other space observatories were brought into the investigation. The Hubble Space Telescope, though aging, still had valuable data archived. Teams combed through its spectrographic readings, looking for any hint of DMs or corresponding biosignatures from earlier observations of K218b. The results were inconclusive, though intriguing. Hubble had seen hints vain easily dismissed at the time, but hints nonetheless. They didn't prove Webb's discovery, but they didn't contradict it either. Meanwhile, Earth-based telescopes turned toward K218b with renewed purpose. The Keck Observatory in Hawaii and the Very Large Telescope in Chile directed their massive mirrors and adaptive optics toward the red dwarf system. However, observing such distant, dim targets from Earth is notoriously difficult, especially when searching for trace molecules in alien atmospheres. The limitations of Earth's own atmosphere, rich in water vapor and other interfering gases, blurred the precision needed to match Webb's clarity. Still, scientists persisted, using every trick at their disposal, trying to find independent confirmation that would either support or dismantle the discovery. But the Webb telescope itself had more to offer. Orbiting at Lagrange Point 2, beyond the moon's gravitational tug and shielded from both Earth and the sun, it could watch K218b without interruption, free from atmospheric distortion. Over the next few months, it continued to collect data each orbit, each transit adding to the statistical weight of the discovery. The DM signal did not disappear. In fact, it became sharper. Methane and carbon dioxide remained consistent. The atmospheric chemistry stayed steady, almost as if the planet itself was breathing a predictable rhythm. And then something unexpected happened. In one of Webb's deeper observations, scientists noticed a subtle shift in the planet's atmospheric pressure profile. The upper layers of the atmosphere, those exposed directly to the parent stars, initially dismissed as noise or random turbulence, the patterns began to repeat, forming regular cycles. Planetary atmospheres often shift. Yes, but rarely with such precision. Some hypothesized jet stream systems or cloud cycles, but others quietly proposed a far more radical theory: structured weather on Earth. Complex cloud systems and pressure patterns are often the result of biological processes. Forests breathe, plankton bloom, organisms release gases into the air, subtly shaping climate and cloud formation. Could something similar be happening on K218b? The idea was staggering. Not just life, but an ecosystem, perhaps even a biosphere with interconnected biological processes shaping the world's climate in measurable, predictable ways. It was a hypothesis no one dared to voice publicly yet. But the possibilities sat heavily in the minds of those closest to the data. Meanwhile, the search expanded. K218 billion was not alone in its peculiar chemistry. The Webb telescope, now emboldened by the discovery, began targeting other potentially habitable exoplanets with similar parameters. A second planet, smaller and more distant, showed hints of another biosignature, possibly nitrous oxide, a gas closely associated with microbial life on Earth. But the signal was weak, buried in noise. Still, the trend was unmistakable. The more planets Webb looked at, the more strange lifelike chemistry began to emerge. It was becoming increasingly difficult to dismiss. If only one planet had shown signs, it might have been a fluke. But 3, 4! If these signals were confirmed, it would mean that life, or at least the conditions that foster life, might be common. It would suggest that biology is not some rare accident of Earth, but a fundamental process that emerges naturally when chemistry, energy, and time align. The psychological and cultural impact was immense. For centuries, humans have stared up at the stars, wondering whether we were alone. Religion, philosophy, and science have all wrestled with that question. Now, for the first time, we were getting an answer not from dreams or stories, but from the hard edge of data and spectral lines etched into deep space starlight. In cities around the world, museums and science centers scrambled to update exhibits. News anchors struggled to explain spectrographs to mainstream audiences. Children pointed telescopes toward the stars with new air. Even the language of science began to shift. Terms like biosignature, exoplanetary ecosystem, and probable life-bearing world began to enter common usage. This wasn't just a scientific breakthrough. It was a civilizational turning point. Yet, for all the excitement, there was still one great unspoken fear. What if we misunderstood? What if we were seeing patterns that weren't there? Reading meaning into noise, falling for the oldest trick in the human brain. Parad, the tendency to see faces in clouds and meaning in randomness. Were we truly observing the breath of life? Or were we staring at a cosmic Rorschach test, projecting our deepest hopes onto data we barely understood? This is why Webb's mission began to evolve. Originally tasked with studying the early universe, it was now becoming something else, a seeker of life. The telescope's planners had always dreamed of such a discovery, but now that it seemed possible, they had to rethink their priorities. Observation schedules were revised. Resources were reallocated. Entire departments within NASA and ESA shifted focus. Webb, it seemed, had stumbled into a new era of science astrobiology at galactic scale. In private meetings, government officials began to take interest. If alien life was real confirmed, what would it mean for geopolitics, for religion, for global unity or division? Could this be weaponized, exploited, hidden? Those discussions remain classified, but leaked memos suggested high-level briefings and contingency plans. The discovery had entered a new domain, no longer just science, but policy, philosophy, and the raw nerve of civilizations, self-perception. And still, the data kept coming. Back on Earth, the next generation of telescopes, both space-based and terrestrial, was being accelerated. The European Extremely Large Telescope, still under construction in Chile, now had renewed urgency. NASA's LoveWar and Habax missions, both designed to image Earth-like exoplanets, directly were pushed toward faster development. Prototypes for star-shaped technology, designed to block starlight and allow clearer imaging of exoplanets, were suddenly a top priority. Humanity once content to wonder, was now preparing to see. And then came the signal. Not a message, not a radio wave, but a spectral anomaly unlike any yet recorded from a different exoplanet entirely. This 140 Webb telescope captured a fleeting flash in the atmosphere, a sudden spike in light emission consistent with chemical excitation. It lasted less than 3 seconds and was never repeated, but its chemical fingerprint matched something oddly familiar: chlorophyll, or at least a molecular structure functionally identical to it. On Earth, chlorophyll is the molecule that powers photosynthesis, the process by which plants convert sunlight into energy. It is, in many ways, the heartbeat of the bio. If a similar compound existed on this other planet, it could suggest not just life, but sunlight-driven life plants, or something analogous to them, transforming stellar energy into biological fuel. Again, caution dominated. Could it be a coincidence? A geological outburst? A cosmic ray? But as with DMs, the specificity of the signature was deeply unsettling in its precision. And once more, the same question echoed through the halls of academia, across the floor of parliaments, in whispered prayers and shouted debates. What if this is real? By now, the world was listening. A new kind of public consciousness had emerged, curious, skeptical, but profoundly aware. Documentaries flooded streaming platforms. Artists, musicians, and poets tried to interpret the unfolding story in their own mediums. School children memorized the names of exoplanets instead of constellations. Humanity was no longer just looking out, it was leaning forward, reaching. Still, James Webb kept watching. Day after day, photon by photon, it peeled back the universe's secret. Each new observation carried with it the potential to reshape what we knew about life, the cosmos, and ourselves. And though no alien cities had been found, no radio signals received, and no spacecraft spotted, what the telescope had discovered was perhaps more profound. Life, it seemed, was not a fluke. It was not the isolated miracle of one blue planet. It might be a rule, not an exception. And with every passing month, as Webb continued its silent vigil among the stars, we came closer to accepting a truth that once lived only in our dreams. We are not alone. We never were. We just hadn't known how to listen. Now, finally, we do.